Chapter 2 review for the Year 12s. We've done this one here. We did it together in class. I probably should redo it for you as well. But just looking at 24, they've given it a triple star. I don't know why, because it's fairly straightforward, I think. 8 kilogram carton of soft drink being pulled up the slope. It's being pulled parallel, so there's no working out any components of that applied force. 45 newtons. Calculate the acceleration, if any. So if this force is greater than, it's frictionless, the whole thing. So if this force is greater than the parallel component down the slope, so if that force is greater than this force, then it's going to accelerate up, and vice versa. If the weight component down the slope is greater than that, it's going to accelerate down. So calculate the acceleration, if any, up the incline. So for acceleration, you must have a net force. So we're going to check the size of F parallel against the applied force. So calculate up here. 78 is the weight. 8 times 9.8 is 78.4 times the sine of 30 gives you 39.2. So we've got 39.2 down the slope, 45 up, so it is going to accelerate up the slope. 5.8 newtons net force up the slope. We got the mass is 8 kilos. We arrange that. It's going to accelerate 0.725 meters per second squared up the slope. Pretty straightforward. Decide what the motion would be if the applied force was 40 newtons. So instead of 39.2, we're going to have 40. So it's just a decrease in the acceleration. So the net force now is 0.8. F equals ma, 0.1 meters per second squared up the slope. So why that has 3 stars, I do not know. This next question is the interesting one. So 25. Students were asked to investigate the relationship between the angle of elevation and the parallel component of the weight of an object on an incline. So some sort of set up a bit like that one there. They set up the experiment with a 1.2 meter long aluminium ramp, varied its elevation through a range of 10 degrees. The length of the ramp doesn't matter. 10 to 50, they used a Lego car of mass 75.5 grams. Watch out for that, you'll need it in kilograms. And they used a weight over the side to pull it over a pulley. So they've got the angle, and then that is the mass that they had hanging to keep the car stationary, so it wasn't going down the slope or up the slope. They hypothesized that the weight of the hanging mass would equal the parallel component of the car's weight down the incline for each angle. Well, that makes sense, doesn't it? So they're hypothesizing that the weight of the hanging mass would equal the parallel component of the car's weight. They plan to plot a graph to help confirm their thinking, analyse their data, and evaluate their hypothesis. So we know that we need the sine of this angle, and we're going to need that in newtons. That hanging mass, we need to convert that to a weight. So I've redone the little table. So I've got theta, sine theta, and then the mass and the tension, which is equal to the parallel component because the car is just sitting still. So I did all those little sums, and then I plotted a graph of F perpendicular against sine theta. And yes, it is a straight line, or appears to be a straight line with my rough little graph. Right, so we can say that the parallel component of the weight of the car down the slope is directly proportional to the sine of the angle of the inclination. And this bit then, if you use Excel, you'll get this as the equation, y equals 0.751x minus that. And you could use that to get a value for g. So we know that the tension is equal to the parallel component, and the parallel component is mg sine theta. So if we get the slope of our line from up here, we've got mg sine theta, sine theta. So the slope is going to be mg sine theta, and we get a value of 9.95 for g, using the mass that they gave us for the car, and you get a percentage error of 1.5%. Now it's a little bit, this is my second go at this question. When I first had a go at it, I was looking for something else. I think there's a mistake in, this is the sort of answer that is in the answers, but when it talks about what they hypothesized, they hypothesized that the weight of the hanging mass would be equal to the parallel component of the car's weight. See, I think that's wrong. It should have been something about, they wanted to look at the relationship, or they hypothesized that the parallel component was directly proportional to sine theta, which is what the answers graphed. So I think there's a mistake in that. It should have been they hypothesized something else to get that. Because this, the parallel component of the weight down the slope is directly proportional to the sine of the angle, does not match their hypothesis. So I think that's just a mistake that's in the text again. But if you're asked to analyse and evaluate their hypothesis, presuming the hypothesis is not this one, you would be able to make a graph, find out what kind of relationship is involved. If you're using Excel, then you're going to get the equation as well. So you can work out a value for one of the givens.